Hey Terry, I just wanted to make things easier for you by making a video and explaining what you need to do for tomorrow. Tomorrow you should not have any students in first period, but if you do, these are their instructions. They have a take-home exam and they're supposed to be working on at least question number 1 and 3, if not 2, 4, and 5. They should be able to do 1, 2, 3, 4, and 5 all on their own. I want the rough draft by next Tuesday. I'll change that before you get here. They need to have that done by next Tuesday. At least have a rough draft. And you can, if anybody's here, you can help them. They can more than welcome to use the internet, but I really want them to use their notes because there's a lot of good stuff in their notes. This is what the assignment looks like. Basically, what the kids are supposed to be doing is, in this stage, putting together a short sort of explanation of overfishing. So I've broken up into 5 pieces, and I told the kids, if you can answer these questions, then you should be able to introduce overfishing or explain why fishing is a problem for the economy or social stability, those sort of things. I'm not expecting, some novel. I just want the kids to start thinking and being able to regurgitate what I've talked to them about. This is technically a take-home exam, but really it's just kind of a project. The take-home exam part kind of gets them moving on it. Otherwise, if I don't say take-home exam, they don't do anything. So anyway, if they're here, let them work on this, and that's about it. They've got the whole period to just work on it. Now, for FBC, you're going to be doing a lab. Let's see, right here. It's the inertia lab. Inertia states that an object in motion stays in motion, and an object at rest stays at rest. The kids should have a packet that looks like this, and there are all these little labs. For instance, there's a mini lab, Coin Magic. Coin Magic is one of them. This is what it looks like, and to make it a little bit easier, I'll stand it over here. Okay, so an object at rest stays at rest, an object in motion stays in motion. The way this one works is if I use a low amount of motion here, the stack of coins will stay on the slip of paper. Now, if I use a quick motion, they'll stay there. What I'm doing is I'm overcoming friction by pulling this away really, really fast. And so this is an object that's at rest. It wants to stay at rest, so it stays at rest. All right, another demo, another station that they have is Crash Bang. That's this one. The kids basically have to take a stack of wood blocks. It's a little bit easier for me since I'm right-handed. And they have to bang one of the bottom pieces of wood out so that the other ones fall down straight. And this is the way it should work. Yay, it happened on the first try. If they do it right, this is sort of like the coin one. I am overcoming the inertia of the bottom piece, but in general, the rest of the stack is at rest. It wants to stay at rest, but because I overcame friction with enough speed, I was able to get that other piece out before friction could affect the others and move them. All right, another one. This has to do with eggs. You have a hard-boiled egg and you have a regular egg. You can figure out which one's hard-boiled and which one's not just by shaking them, also by turning them. A hard-boiled egg should turn really easy, like this one. This one does not turn so easy, and that's because the egg yolk slows it down. Again, an object of motion wants to stay in motion. The yolk in this wants to stay in motion. It wants to go that way, but the general motion of the egg is in circles, right? If you lead the kids a little bit, they can come to this conclusion. I've noticed a lot of kids haven't had any problem with it. So anyway, that's why it doesn't spin very well, the whole idea of inertia. If you tell the kids to keep each of the eggs in a different bin and to spin them in the different bins, you shouldn't have any trouble. If you need extra eggs, they are in the refrigerator and I will mark them. Should be really obvious which ones are hard-boiled and which ones aren't. Okay, there's another demo. It's called Crash Test Dummies. Basically, one of the kids has to hold this box while the other slams this into it. They're going to see what happens with these little dummies without a seatbelt and with it. And for the seatbelt, there's just this little rubber band, and you should be able to snug them up here. And this teaches them a good lesson. Like right now, these little dummies and stuff aren't moving. Even now, they're technically kind of not moving, but at the same time, they are moving. And you can tell that they are moving because when this thing comes to rest by hitting the box, they will continue to move, unless the seatbelt breaks up the inertia. And that's that demo. So there's that. This one is called Paper Power. You have a piece of paper like this, and the kids have to hold it and poke it and try and poke a hole through it. Now, in this case, the piece of paper is at rest, and it's stiff, laying at rest. If they can poke it quick enough, it overcomes inertia, overcomes the motion inertia anyway, and they can poke it through just like it's a piece of cardboard or anything like that. All right, last one. Last one is the spring. You can go to Colorado FET and just go to their simulations for physics. The kids put the springs on here, and it'll go up and down and up and down. Now the friction is in action, so if you decrease the friction, this will continue on forever. But that's because there's no force acting on it. So this is a great example of inertia, because something in motion will always stay in motion, especially if there's no force acting on it like friction. That's basically it. I gave the kids about 6 minutes for each station and gave them a 2-minute warning to play around and then 4 minutes to write stuff, and then I blew the whistle. And it was a nice little clockwise circulation. And that was about it.